This is Mrs. Schroeder. Welcome back to chemistry. We are going to be covering the periodic table in this chapter, beginning with section 4.1, which talks about the elements and how the table is organized. Our goals today are to talk about the historical development of this table and how the modern periodic table is actually organized. Scientists who were responsible for the periodic table development begin with John Newlands. He was an English scientist. In 1865, he came up with the law of octaves. What he found was that atoms repeated their properties every 8 elements, 8 being an octave, if you are musically inclined. But he noticed they repeat. They react the same way. They have, if they're a solid or a gas, or they react with a certain thing every 8 elements, it'll repeat how it acts. So he called this the law of octaves. Now, next guy, Dmitry Mendeleev, is a Russian scientist. In 1869, he came up with the first periodic table. What he was trying to do was he was trying to make some cards, and he was putting all the properties, everything they knew about the 63 elements that were known on some cards. He was a teacher. He wanted to teach his students about the elements. And as he was looking through his cards, he was realizing there were some things that were alike. And using Newland's law of octaves, he was able to put together a table that based on the mass of the elements. And what's important, people had tried organizing elements before, but what was important in Mendeleev's table is that he had gaps. Okay, gaps being something that was empty. Now, if I was playing with a deck of cards and I was checking to see how many cards I have, and I start laying the cards out, and I find out that I have my diamonds has a 1 or an ace, and then I have an ace that, or then I have a diamond that's a 2, diamond is a 3, my next diamond is a 5, I would then know something is wrong, because I know what to expect. I know that there should be something here with a 4, but I don't have it, so I know something's wrong. Now, back in 1869, we didn't know that we didn't know all the elements. We had 63 of them, felt pretty good about it. But he was actually able to say, you don't know everything. And what was really important is he could actually predict the properties. He was able to say, I think we're going to find this element, and I think this certain element is going to have this density, it's going to react this way, it's going to look a certain way, it's going to have a certain mass, and a few years later, they will define elements that fit his. This is what Mendeleev's periodic table looked like. Again, it doesn't look like our table now. Our modern table is laid out differently. But if we look across at the rows as we go across, so we go from lithium all the way across to fluorine, okay, we see that his rows also goes from lithium across to fluorine. Those elements are all the same. Now, what he doesn't have are the things over here. He doesn't know that there's neon over here or helium, because these are noble gases. They didn't react. Back in 1869, they didn't know them. There's also a few other things that he didn't know to predict, one of those being germanium. A couple years after he came up with his table, they actually found germanium, and it had almost exactly the properties that he predicted, which made a lot of scientists believe that his table was correct. Now, Mendeleev's table was great because he could predict elements that we didn't know, but he had a problem that he couldn't understand. He had to switch some elements. Again, he was arranging things by mass, and he chose to arrange them from lowest mass to highest mass, but there's a few places where he had to switch back and forth where the higher mass atom actually had the properties of the lower mass atom, so he switched them to make sense. But again, because he had to switch them and couldn't explain it, we can't accept his as 100% correct for his table. So Ed Mosley came along a few years later, and he looked at the spectra of the elements and figured out that if we arrange things by atomic number, not atomic mass, we don't have to worry about flip-flopping things and switching things around. He could actually explain the arrangement, and there's only a few elements that actually changed, but it was a way of improving on Mendeleev's table. And he found that the periodic table that he set up now has patterns in 2 dimensions, going down and going across. A couple other definitions here. Periodic law is the repeating physical and chemical properties when elements change with their atomic number. Okay, a group is the vertical column of elements in the periodic table. So if I look at things that are going down, okay, and a period is the horizontal row. So a group is going down, a period is going across. Okay, so where did our modern periodic table come from? Okay, this was a gentleman named Moseley that came up with the idea to rearrange things by atomic number now. So now we arrange things as if it has the atomic number correct. So now we have groups that go down based on the same family. So fluorine, chlorine, bromine, iodine are all a family. They share the same chemical properties. They'll react the same way. When we go across, we're going with increasing atomic number. This was the way Moseley set up his table, which is what we consider the modern atomic table, the modern periodic table now. So this is a period. This is the second period of the periodic table, because it's the second row of elements. Now a valence electron is the electron in the outermost shell. What's important about valence electrons is this is what determines the chemical properties. So if we're saying that elements in the same family or the same group react similarly, and we said that electrons determine the chemical properties, it goes to follow that if they have the same group, they're going to have the same valence electrons. We're going to be using our orbital filling from chapter 3 to figure out how electrons are filled, and tomorrow in class we're going to continue trying to find out valence electrons. Again, relating this back to the periodic table, we find that based on our energy orbitals, the s orbital has 2 electrons. One goes up and one goes down. This row and this row. Okay? The first group has 1 in the 1s, the second group has 2 in the 1s. Okay? And we can go over here and we can look and say this is the p block. And the p, if you remember, has 3 orbitals. The first electron, second, third, and then the 4th, 5th, and 6th. And they fill going across. So again, tomorrow in class we're going to spend more time figuring out valence electrons, learning how to use the periodic table to determine valence electrons, because that's really the heart of why things react the way they do in chemistry. So we will see you in class tomorrow, and be prepared to discuss valence electrons.